AIAA, American Chemical Society, and IEEE to join hands together to celebrate this Earth Day and celebrate the environmental movement to raise awareness of pollution and ways to maintain clear habitat. We have very distinguished speakers from all over. We have Professor Sidhu from Canada. He's an expert in molecular genetics. We have Dr. Brady, who is the chair of American Chemical Society, Southern California. Professor Madhu Thangavelu from USC, who's a moderator. We also have Dr. Joao Teixeira, who's from JPL and Climate Science Director. We have Brett Cornick, who's representing the young professional. Eric Jessen from Raytheon. Marty Waldman and Professor Craig Smith from Nuclear Power Grids and Clean Energy. Dastani Khalili from Cal Earth, who's a panelist. Jane Pointer and Tabor McCullen from Space Perspective is a panelist. We have highly distinguished, but originally it was planned to be a short event, but we decided to add more speakers. So things have gone a little bit further down. I'm pretty sure we have a lot of questions for these speakers. I don't know, I will let the moderator decide how he wants to pursue the question and answer session. So I will describe a little bit briefly about AIAA, and then I will give the mic to Dr. Brady for introducing the Southern California ACS. At AIAA, our purpose is to ignite, celebrate, and aerospace ingenuity and collaboration, and is important to our way of life. Our promise is to be your vital, lifelong link to the aerospace community and a champion for its achievement. AIAA Los Angeles Las Vegas section is a home to one of the largest number of aerospace companies in the world, with a highly dense population of aerospace professionals. We have Boeing, SpaceX, Northrop Grumman, Virgin Galactic, JPL, Aerojet Rocketdyne, Lockheed Martin, Raytheon, Aerospace Corporation, Scale Composites, Booz Allen Crane, Aerospace, Honeywell, L3 Robotics. Just name every company and we have it in the vicinity of within 1 to 2 hours from our section headquarters. The section is community of nearly 10,000 aerospace professionals, their family and friends. Dr. Ken Liu has worked hard to organize this event, contacting all the speakers and stuff, and we appreciate his help. For those who don't know, AIAA is a non-profit organization. It is run by volunteers. None of us get paid for the volunteer activities. We are passionate about the aerospace, and that's why we do the work that we do. If you want to volunteer, please contact me or Ken, and we'll be happy to involve you in some of the activities that we are having. COVID-19 has made all of us to work from home. Many of my friends are going through job transitions. We have nearly 30% unemployment rate, probably one of the highest in long time. As per LA Public Health Department, the number of infected people in LA County itself is 18,000 and number of deaths are 848. Although we hear that 15th of May is the lift-off date of lockdown, we prefer not to have any in-person meetings for a long time because many of our section members are at risk, mainly because of their age, pre-existing conditions, or other related issues. So we'll probably be having these web meetings for a long time. So, and we appreciate all the speakers and the attendees for helping us out in this time. Again, if you are not an AIAA member, please become one. AIAA is offering a free 1-year e-membership for those who are not the members. And please try and volunteer to help AIAA organize events. I'll now give the podium to Dr. Brady, who's the chair of American Chemical Society, and he's from Aerospace Corporation.
Hello, can you hear me?
Yes, we can.
Okay, good. So let me just quickly introduce myself, and I'm from the American Chemical Society, and I'm chair of the local section, the Southern California ACS, which we call SCALACS, or SCALACS, and we have a website, scalax.org. I'm also a member of the AIAA, so I second everything that Shakar has said. Normally, we have a lot of activities this time of year. For the American Chemical Society, we spread Earth Day out into a week, and we call it Chemists Celebrate Earth Week, CCEW. And we had 3 events planned for this week, all of which had to be canceled or postponed. So we're doing this event in collaboration with the local AIAA section as our Earth Week event this year. We're starting to learn how to do more things virtually or online. One of our biggest activities every year is the High School Chemistry Olympiad, which normally kids meet at their high schools in a room and take the test. This year we've managed to put all of the tests and all the students taking it online. That was a big undertaking, but hopefully we're all learning and benefiting from this process. It seemed to go pretty well. There's not going to be there's a second step to that test once if you qualify for the first part, and usually the second test, the follow-on test has a laboratory chemistry section, but there'll be no laboratory work this year, I think. Everything is virtual. Again, I want to welcome everyone that came here. I want to thank you for coming. I hope everyone is healthy and safe, and your families are healthy and safe. Like I said, we're going to continue on with virtual activities. Usually, our local ACS section kind of takes a break during the summer. We follow more an academic schedule, but given the current situation, we see no reason to not press on through June, July, August with more virtual activities. So look for some notices from us and maybe some more in collaboration with the AIAA for the rest of the summer. Thanks for your attention. That's it.
Thank you.
Thanks, Brian. Thanks, Brian. Now I think Madhu, you take over the moderator. Professor Madhu will take over the discussions.
Okay.
You may want to introduce.
Yeah. Thank you all. I think our introduction from Dr. Shaker and Dr. Brady have told us all what we are about. It's a very tight program, as you can see. Several people have been invited, and we are happy they are all here. Our idea is to run through the various presentations, and there will be a running thread of questions, which we hope to answer as a bundle, unless our speakers present their slides quickly, and we have a short amount of time between presentations. With that, any other pressing questions, Ken, or any others on the thread right now?
I think it's good to go.
Okay, good. So I'm about to share my slides. Ken, what are we able to see on the screen?
Oh, you want to share? Okay, 1 second. Okay, go ahead, give it a try.
How does that look?
Okay.
Is that good?
Yeah, it's good, but it's not full screen yet.
Okay, let me do it.
By the way, if you want to show your face, you can kind of shrink your video camera and put on the side of the slide, and people can still see your face.
Ken, let's not now. Let's go ahead.
Okay, good.
Go ahead and start.
We have Earth Day, and it is the 50th Earth Day. 50 years have gone by since we started thinking about Mother Earth in ways that we did not used to in our communities. And so it's a very special occasion. And I was invited to talk about what we are doing at the University of Southern California. Some 2 years ago, we thought about how space activity may be a part of human activities on the surface of planet Earth. And so I run a class in the spring in the School of Architecture called Space and the City. So it's all about getting people from all over the world. You'll see people from all over the world in my classroom. And we are constantly looking to see how space activity and space technologies can be useful for people here on Earth. This is my engineering class, which I teach in the fall. In the spring, I teach in the School of Architecture, and in the fall, in the School of Engineering. We have very interesting guests. Buzz Aldrin is a good friend of our studio. He comes online and discusses with us about all the creative things we do. Now, all of us are aware of this part, which is that it's hard to predict anything, including what happened to us just a few months ago. We have speakers who will be talking to that. But all the same, the worst thing we can do is not think about the future. Now, all of you know about H.G. Wells and T.S. Eliot and so on, but they had a very good friend in the name of G.K. Chesterton. And he said, when you think about the future, we must always think and dream as hard as we can and not let policy and politics and other kinds of things get in the way, because the clarity of dreams is the first most important thing we have in our faculties. And that is really the theme I try to use in my classes, both in the School of Engineering and in the School of Architecture. Let's talk a little bit about the space philosophies going on today. These are the various space philosophies. Elon Musk says we have to settle other planets so that humans can survive as a species elsewhere. Jeff Bezos says we have to protect and make Earth beautiful. John Marburger, who used to be our dean at the USC School of Science and Letters, and further he went on to advise the White House under George Bush Sr. He said that we have to bring space into the economic sphere of influence. Joseph Campbell, all of you know from his association with George Lucas, he talked about how mythology and space are connected. And he was, as you know, George Lucas' mentor, also Steven Spielberg. He said, all that we do in space is about coming back and telling the story to all of humanity. Now, our good friend Freeman Dyson, who just passed recently, he said, you look out in space and you see nothing but blackness. It is our job to beautify it by going out and building things that we like to call space architecture. And Frank White talks about how the human spirit and the human mind and the human psyche is changed the moment you go out into space and look back at Earth. He calls it the overview effect. If you ask me, I will go with Jeff Bezos and Elon Musk, who are the leading philosophers of our time. Sometime in the 1960s, an architect and a mystic and a visionary and a mathematician and an engineer and a scientist called Buckminster Fuller proposed an idea that Earth is a spaceship floating in the voids of space. And that caught on very well. And here you see how he has tried to make New York a part of a particular contained self-ecology. I wish this was the case today because of what is happening there. Now, several architects talked about how the future might happen. Antonio Santalia was one of them. He said that the city must change rapidly to make things happen for us in a dynamic area. And he said that every generation must build its own city. What he meant is that we have to evolve very quickly to the new parameters, the new needs of the day. He went on to draw some fantastic imagery during the early 20th century that caught the fascination of many, many architects. This is long before skyscrapers ruled the day. And he died very young during the First World War. The man on the right that you see, that is the young Santalia. I think he died when he was 24 or 25 years old. Now, I want you all to think a little bit about this particular slide I made. It says, space community tends to look up, while most of humanity looks down. In fact, all of space community too looks down. And this is something that will resonate with the rest of my slides, I hope. And it is something we want to pursue. On Earth Day, the 50th Earth Day, we want us in the space community to look more and more towards Earth. I'm so glad that Dr. Teixeira and others are with us today, because we will be discussing how space can affect all of humanity, not the 0.0001% who act, who are active in the space industry. We need to do that not only for humanity to enjoy the benefits of space, but also to impress upon our leadership how space is important for all of humanity. You're looking at an image of on your left, you'll see that small person next to a huge visual. That is Frank Lloyd Wright in the 1950s talking about the mile-high Illinois Tower. And guess what? It's taken us 50, 60, 70 years to get to really build the thing. Right down the middle, you see Saturn V for scale. So the things we do are very small, but we make a big impression. The International Space Station now operates on pure solar energy, something that took 20 years and still taking longer for us to use on planet Earth. And it's a sign of things we do at the forefront of technology that captures the imagination of people on planet Earth. Nuclear power is coming up in a very big way. Here you see Mark Gibson holding up the compact nuclear power systems that has been space qualified. So we are ready to use nuclear power in clean and safe ways. NASA has been thinking about for it very long, and have been studying various ways how to protect people when you're using fission reactors. As you know, we have already had a NERVA program run for a long time, verifying rockets. And now we are able to shrink nuclear power down to what you call from a giant size to something very, very small and very useful on planet Earth. Now there is a project ongoing. Nuclear power plants are very big if you've been around it. And now there are ideas to have modular fission power plants. This one is done by NuScale Power Systems. They want to drive a nuclear reactor to your hometown and start running it in a modular manner. Now, talking about recycling, the space activity has been at the forefront of it. And as you know, we have the environmental control and life support systems. We recycle the water in a very nice way. Up to 94% of water on the space station is recycled. And I think it is high time we do that on planet Earth too. We could think about recycling in our homes. Growing food is another area where station has done some fantastic work. There was a time when they did not want to have anything to do with biology on station, but that has changed now. Besides human factors, we are looking at human physiology, and now we are looking at how to sustain human physiology through growing fresh food. As you know, in the Antarctica, we have always been doing this for about the last 10 years. The Center for the Environmental Control Center at Arizona University has been very important in that development. And the European Space Agency has been looking at doing that also. But growing something like 5 kilograms of food in a week, which has been completely turned upside down by companies like Aeroform, which give us a lot of food, 3 times as much as what's produced on ISS Eden project. Now comes telecommunication, and communications has taken a huge turn in how we transfer, transmit, and use data. You're looking at Google, and Google is one of the companies that's been doing magic. Right now, I'm talking to you because of them, and we are able to do fascinating things with data. Of course, it costs a lot, both in resources and in energy. You're looking at the plumbing lines of a Google server center. It is quite dramatic, and it uses megawatts of power. And they are all over the world, these server centers, and many more are being installed. Of course, and now we know about Starlink. Day before yesterday, they shot up another 60 satellites. That will also change the way we share, use, and appreciate data. Telemedicine is an area that's been growing strong in both in the space industry and elsewhere. Here you see a doctor looking up a patient, and this is happening dramatically all over the place, not only in space, but even more so on planet Earth. Robotic telesurgery, robots in all walks of life are taking over, and you'll see this not as much in some of the less crowded places as we do in the mega cities and the megalopolises, and doctors are able to conduct very, very fine surgery using fine mechanics offered by robots. Now it brings me to chemistry, because the American Society of Chemists are involved here, and I dream of the time when alchemists did magical things. And you may know Sir Isaac Newton, not this person here, but Sir Isaac Newton, he was an alchemist first and foremost before he did Principia and all the other wonderful things he talked about. And in the aerospace industry, it's well known that Mondelloy is an alloy that was made through the good services of Dallas Hardwick on the left side, and Monica on the right, Monica Jablonski, I think, and then Mondelloy is the name coming out of Monica and Dallas. I mean, these are beautiful things, and we use new alloys because many parts in rocketry, many subsystems and systems in rocketry cannot withstand the heat and the pressure caused by oxygen and oxidation. And of course, there is the infamous aerogel that crops up. I know people at JPL will talk more about it, but there's a fantastic story about how aerogel was first formulated at Stanford by a graduate student who went on to become a professor. And I hope you will read about him. Here, just like there is a periodic table of elements, there are always a periodic table of alloys of sorts, and this is a very rudimentary table, but some fascinating things are happening in that area. I think all of you know how the SR-71 Blackbird was built, and how the engines of the Blackbird, the J58, was built. A lot of thinking from chemistry goes on into sustaining the innards of these engines using high temperature materials and alloys. It's one of my most beautiful birds, Blackbird. The Blackbird is one of my most beautiful designs. Again, an aerospace giant by the name of Kelly Johnson was involved in it. And I think all of you will enjoy reading about the intrigue behind building of the SR-71. That is the engine. Again, a magical engine designed through the good services of chemists and amazing alloy technologies. That's the interior of the SR-71. And of course, reverse osmosis is an important area where you think about how water can be purified, desalination. Again, chemistry is involved, so is fuel cells, both in different phases of electrolytes, gases, liquids, and solids. And Bloom Energy, I think you see our friend Sridhar right there, looking towards how we can use fuel cells to make cleaner energy. And just the other day, I heard that 6-junction solar cells using group 3 and group 5 materials are now just coming on board. 50%, 49.6% efficiencies are possible using photovoltaics now. Absolutely wonderful. All thanks to chemists. So now, imagine this, 2050, population, I think it'll be more like 300 world cities. We need to look at energy and transport, water and food for the people, how to contain waste and pollution. We'll have increasing wealth and leisure, hopefully. We have to deal with climate change, species security, which is what we are struggling with the past few months, pandemics. And with that, humanity and privacy are important. We'll hope to have Mars colonies, moon colonies, lunar settlements, and so on. And one way to think about this is to consider how we can build into established cities. What can we do to make cities grow without spatially growing them out, which is already a problem? And one way to do that is what we call the negative Z option, going underground. And we've been doing this for some years. It's not anything new. There are cities in the world that are underground already. Architects have been thinking about it for a long time. And here you see some of the works of Paolo Soleri about going underground and living in very compact and highly dense situations. Now, the connection between going underground on Earth and elsewhere is through lunar lava tubes on the moon that we have seen over the past years. We've known they exist, but it's only in the past few years, I think the past 10 or 12 years, that we have known that we have access to them. You know, if you look at some of our early drawings, you'll see drill jigs going into to access lava tubes. But now we know nature has already done it for us by meteorites striking right into the surface and exposing what we call skylights that take you down into the surface. So we know that underground is a good thing to do. And we study the physics of it, we study the thermodynamics of it, and we know that they offer stable environments in which to protect ourselves and to live comfortably. And here are some images from our class, talk about how to enter the lava tube and construct habitats. We also know that solar power can be beamed down from space, which is a far more efficient, but at this time, a far more expensive way to do this and be able to serve underground cities. Data communications can be done by sub-satellites, which are much, much, much cheaper. The Loon project of the Google enterprise is one of them, where they float balloons with the transponders on them that allow communications. Underground habitats and cities have been designed in the past. Several are already happening in the colder parts of our world. And you know, we can see more of it coming up in the years to come. London has a deep underground system, Washington, DC, New York, Boston, they all have, and particularly when you go into Canada, you'll start to see how underground infrastructure is waking up to reality. And this is what underground cities can offer. Many, many things besides utilities. We have automobiles, we have transit lines, we have and now we even have gardens in underground London chambers that were used as bunkers during the Second World War. Mining and boring technology is very vital to this underground vision that we have about making cities more livable. And I think all of you know the Bertha machine that was used to mine, that was used to tunnel under Washington state, and how big these things are is still quite impressive what they were able to do. That is the DC Metro, I think you're familiar with. So we are able to do very large, I think all of you know about the Channel Tunnel. And so we are able to do mining underwater, under oceans, under lakes, and thus we hope to see fascinating developments in that area. Now, regarding tall structures, we have been doing some good things in tall structures, and they are faced with certain problems. So we cannot keep going tall all the time. So there are some limitations caused by HVAC, by solar insulation, and also the sheer fact that we can only do sectional works on very tall buildings. Virtual windows allow us to live very nicely and comfortably underground. There are some fantastic doctoral dissertations by people who talked about how underground could be used using virtual windows. These are some of the ideas that we talked about to bring things underground and overground as well. Vertical forms that can cause fascinating new developments, and even underground, going under the ocean floor. We thought about ideas that could possibly have implications for existing cities, historical cities, that we do not want to disturb the top or the skyline off. And these are some of the visions that students produce in our school about what we can do in the coming years and how we are able to make cities more livable, more compact, and more energy efficient. Which brings us to transportation and travel. As you know, this is a rough idea about how many flights happen during the course of a day. And we are thinking of using rocket ships to do the same. And the big difference being, ICAO tells us that in the next 10 years, we will have 30% more airplanes flying all over our skies and polluting it with jet fuel. But if you look at rocket ships, we produce the cleanest exhaust ever imaginable. Not this particular rocket, but the SSME and the RS-25 operate on hydrogen and oxygen. Again, a chemist's magical way of putting things together that is quite pollution-free. It pushes out pure water under high pressure and high temperature. We think we can fly to different places using these rocket ships, very clean ways of doing it. And as you know, Elon Musk is already talking about very quick transit. While our eyes are focused on space again, looking outwards, the real things are happening down here. We want to fly people between megalopolises using very large rocket ships that fly using oxygen and hydrogen as propellant. In conclusion, I think all of you know about Rockstrom's work. If not, you should really visit with that. The green area is what the Earth can afford to do, but many things are going beyond our control. Time to rein in and stop the unruly and dangerous way of dealing with dealing on equal terms with planet Earth. Population is growing in a very, very fast manner. We don't see that as much in the US as we would in India, Africa, and perhaps Central America and South America. And this is how we expect it to grow in the next 10 to 20 years. And people are migrating from the rural areas to the urban areas, seeking economic benefit. And this is going to be a very interesting period for architects and engineers to work together and bring the space community in to make the problems, just solve the problems. We know that carbon dioxide is a problem, so are other polluting agents. But all of us need to remember that we cannot blame ourselves for everything. We have certain natural cycles. The sun is to blame for some of it too. And as you know, this spacecraft have been really looking at the sun recently. There is one mission in flight and several others before that we have looked at. And again, jointly with different space programs of the world, we are able to study the sun in more detail. Now, I want to tell you something about the good part of all the terrible things that are happening. That is, some years ago, long before climate change or the cliche global warming was talked about, I met with this gentleman who just passed on recently. His name is Freeman Dyson, and I told him, what is going on with the carbon dioxide? We'll not be able to breathe anything. Freeman looks at me and he says, you know what? The planet is going to go green faster than you think. And guess what? That is an image of things turning green right now. So physicists have a cool way of thinking about things too, besides chemists. Climate change is causing havoc for us, and we have pollution problems, PM 2.5. These are all satellite images that tell you what is happening. You have nitric oxide problems, but you know, these are things we have solutions to on in space technologies. Professor Lovelock says that the best thing to do in adaptation is adaptation to changes. We have to become a tougher species, something to think about. So the lesson to humanities is we have to become more aware of our surroundings. We have to become more sensitive. We need to respect Mother Nature to decrease our ecological imprint and footprint, and tough up and learn to roll with the punches. So there are several ideas here that we can use. And there are underground cities already working. Anybody know this one? This is Coober Pedy in Australia, where 2,000 people live underground. It allows us to keep the surface for very special purposes. And we can do that using space technologies. I like this quote from Buckminster Fuller. Again, he says, it is very feasible to live with a higher standard of living now. War is not the answer. And we have to change our thinking from high technology for weaponry to high technology used for livingery. And as you know, Buckminster Fuller was not much of a chemist, but you know, the Buckminster Fullerene is something that chemists named after Bucky. And Buckminster Fuller wrote a book called Spaceship Operating Manual for Spaceship Earth, and in which he says that the most important thing is that the planet Earth did not provide us with an instruction manual. And that is what space technology can offer us, ladies and gentlemen. We have to fix our planet. We have to fix our cities. Some years ago, I sat in a lecture, at a Harvard lecture by Ian McHorn, and he said that when the good Lord would look down on Earth, he would say, next time, no brains. And sometimes it is our brains that is causing a lot of the trouble, it appears to me. So let's fix the planet. Let's protect our species. I know prediction is difficult, but one thing is sure, and that is right now there's a program called the Trillion Trees Program. We can go plant trees. They're doing this all over the world. It has a tremendous impact on global warming if done right. The World Economic Forum talks about it, and composting is a thing that we are all doing. We are taught to do that as Boy Scouts, and we should continue to do that. Make Earth great again should be our motto. And thank you. It's our 50th year. Let us think again towards making Earth a good and viable livable planet. Some references here for those who want to enjoy. Thank you very much.